Let's have a look at something that is happening today and will happen much more in the near future in the air transportation landscape of the world and also in our country. And that is urban air mobility and the traffic management of unmanned aerial systems or UAS. What is meant by urban air mobility or UAM? We know that there is a massive congestion in urban areas which is becoming a huge problem. This is especially true in large cities where people are spending hours on end in getting stuck in the traffic in their regular commute. To name a few cities which are suffering from massive road congestion: New York, Paris, Tokyo, Beijing. In India, Mumbai, Pune, Bengaluru, etc. are hotbeds of traffic congestion. In fact, every city that we know of is slowly suffering from traffic congestion. So therefore, there is a need for providing solutions to road transportation congestion, and that could be, one possibility could be urban air mobility. In Mumbai, for example, the congestion rate is approximately 53%. Okay. So the ideas of air taxis are gaining prominence, and in many cities such as in the Middle East, in Dubai, they are in the testing phases at the moment. But very soon we will start seeing urban air taxis in India also. Now the commercial implementation is possible as early as this year, but we have to see how it is actually executed. Now UAM also stands for drone delivery and air taxis for cities and suburbs. Now, what is the current and the future of UAM? Currently, we have a driver which is actually a pilot in the vehicle, and there are 2 passenger seats available. Okay, that is the current situation. In the future, we are going to look at driverless aircraft or driverless air taxis, which will probably have 4 seats. They may expand further, they may carry more payload. So, free flight is going to be a very useful thing which will enable UAS to happen more frequently. It will be an enormous nightmare to control these air taxis by the air traffic controllers and the current network. It is simply not possible because the numbers will be quite large and there will be too many of them. So, the entire urban air mobility traffic management comes under the UTM. Drone and air taxi operations in similar uncontrolled airspace, they will give similar challenges such as operating aircraft in uncontrolled airspace, and air taxis may operate at a higher altitude to keep them away from the drones which are meant for the delivery of objects. They will probably operate at low altitudes and the air taxis may operate at high altitude, but much lower than the one at which commercial aircraft operate. Now, what is meant by advanced air mobility or AAM? This is an umbrella concept. Okay? This concept includes regional air mobility, that is the urban air mobility, but not only in the city but intercity and also from cities to rural areas. So that is the regional air mobility. So the advanced air mobility is the urban air mobility and regional air mobility. So air taxis which operate within the city and air taxis that operate from one city to the other city and from a city to the rural areas. Now these concepts are going to be practical possible only when systems like NextGen and SESAR, they are implemented and tested. Without that, it will be very difficult to have them. Let us look at the UTM for drone delivery. So the last mile delivery by drones is gaining momentum. Already many trials have been done. Already many companies are looking at expanding their deliveries using aerial vehicles. So the drone usage historically has been in the military. Currently in the civilian environment, it is used for aerial surveillance and monitoring, to collect some data for photography during events. For example, it is very popular in India during weddings. There are many drone pilots who make their living by providing photography during the weddings and other events. Then they are used for racing, leisure activities, and in some areas for medical deliveries. In the future, we are going to look at drones for more medical deliveries, delivery of maybe organs or blood to bypass the traffic and to reach the hospitals very quickly, or to reach the area where they are needed very quickly. Last mile product and food deliveries are also expected to happen using drones. Now, the market studies are forecasting more than 100% demand increase for the last mile deliveries, and they have also found that around 84% or more of these products are drone deliverable. They are small, they come in small packages, and they are within the purview of the existing drone technology. But it is easier said than done. There are many major issues in the UAS traffic management of drone delivery. Okay. The current ATM infrastructure is absolutely insufficient and inappropriate in many ways to handle the UTM. It cannot meet this demand. Drone operations are going to happen mostly in uncontrolled or class G airspace. So, therefore, the air traffic control services cannot be provided there. Okay. So, we know about the airspace. So, the UTM operations are going to happen only 400 feet above the ground and within the airspace around that location. So, those are the locations where you cannot provide air traffic control. Now, what is the present and future of UTM? Uncontrolled drones in urban space are going to be a major safety risk because they will collide with each other, they will collide with buildings, they will get stuck in the wires, and they may also create problems of collision with other moving objects like cars and vehicles. So, already there are huge safety risks anticipated. Now, current, we only allow remotely piloted UAVs. We do not allow manned manned air taxis to fly. Only remotely piloted UAVs are allowed. We do not allow autonomous UAVs to fly and deliver the items. Okay. In the future, they will be automated, but you will require massive controls, and we have to think at new paradigms of providing control, ensuring that they operate safely. So, the UAS traffic management or UTM, it will have a absolutely new framework developed for for this particular application. You cannot use the existing and the current protocols directly in this application. So, what are the key features of UTM? Development of airspace to accommodate drones within the currently available airspace, marking out areas where drones could be used safely for doing these activities. We have to also develop a phased plan to roll out the drone delivery so that it happens in steps. There is some experience, lessons are learned from any incidents that take place, corrective measures are brought in, and then slowly the scope of the deliveries is increased. Then we have to also decide on regulations in the current scenario. So, today when we start these activities, there have to be very strict and controlled regulations, but later on as we get more and more experience, then these regulations can be relaxed later if it is found that they do not really affect the safety that much. We have to develop traffic flow and control framework for these drones, and we have to also ensure that we maintain safety of all stakeholders involved, not just the drones themselves, but the environment in which they are operating, the human beings in the vicinity, the animals in the vicinity, then other buildings, other, so the stakeholders are many. It is not just the drone itself or between two drones. It is to do, you have to have a safety of all stakeholders, only then it is going to be workable. And the only way currently that it seems it can happen is to have a central management system for all of the above. Not very easy, easier said than done, but then this is the area of research, this is an area of emerging technology. Let us have a look at the issues regarding UTM drone delivery. Okay? The civil aviation authorities and government bodies, they are currently taking care of the UTM for the drones. The first countries to create and provide frameworks for this are the US, Europe, Japan, China, Korea, Australia. These are, and Singapore. These are the first countries to develop the framework, and others are slowly adapting. India is to follow the European plan, and many letter of intents have been signed. So, we are already on track, we are already moving in that direction. Now, what is required is to integrate with UTM to ATM. They cannot operate in isolation of the existing air traffic management networks and systems. So, you need to integrate UTM, that is the UAS traffic management, and the aircraft traffic management or air traffic management, at least around the airports and in the areas which are restricted. We need to have direct control. One of the models in the US, it opts for corridors with TCAS equipped drones, but TCAS is going to weigh a lot. It's going to cost a lot also, but it's also going to weigh a lot. So, this is only possible for heavy drones. For small drones, you cannot have TCAS equipment mounted. So, this is one way of doing it, right. There are many challenges in drone delivery. Let us look at that. First of all, there is a direct link with the CMS. Okay. Then communication has to be connected with the CMS. Then the navigation is going to be using GPS and 5G networks, right. Then surveillance has to be using two kinds of sensors. There are sensors which are collaborative, that means they have information about themselves and also they have information about the other vehicles in the vicinity, so that they do not collide or there is proper separation and you can detect and resolve the conflicts. You can also have non-collaborative, where there is a solo operation, only one vehicle is operating in that area, so it just needs to take care of itself and the obstacles around it. Very soon we are going to end up with massive congestions in the bandwidth, because as the number of these drones increase with time, it will be difficult to handle with the current communication networks. So, here is a table taken from a journal paper that talks about various kinds of systems which are being proposed. ADS-B type system is a collaborative system. It can detect within about 240 kilometers. It gives you location, altitude and speed, and it has the capability of surveillance as well as communication. Then you can have TCAS, ACAS, XU. This is also collaborative, but the range is less. It is about 160 kilometers. And it gives you only distance and altitude. It does not, but this is going to be heavy in weight, as I mentioned. It will be difficult to equip this into the unmanned aerial systems because of its weight. Then one can look at non-collaborative kind of detection. You could look at optoelectronics systems. These can only look at 20 kilometers or so. They will give relative bearing and elevation, but they are very much susceptible to weather conditions. If the clouds are very dark, if it is dull, then they will be, because it is optics, it needs light, and then it lacks in the guidance range. Then one can also use synthetic aperture radars or SARs, again non-collaborative, little bit more range, and it gives distance and relative bearing, but accuracies are lower. Then you can use light based radar. This has only a very small range of up to about 3 kilometers. It just gives you distance and gives you only the small view. One can use infrared systems, again non-collaborative, little bit more range compared to LiDAR. It gives you bearing and elevation, but not applicable to the IMC, and transmission is very slow. Then one can have acoustic systems. These can have delays in timing. One can have visionary systems or camera based systems. Their ranges are quite small. So many of these systems are being tested out, and trials are being done all over the world to check which of them works most safely. Now, the separation between the flying drones and other objects is going to be a very, very major issue. Therefore, initially there have to be very conservative bounds, and you will have to look at the real life multi-drone scenario that has to be investigated. Then the models that we use are going to be time based models, because over time there will be changes in the distances between the two drones. It will also be distance based, and it could be both or common, right. one can look for static or dynamic separation. Okay? So, the air traffic management would be dynamic, but currently the UTM is going to be static. So, in static separation, what you do is you ensure that there is a minimum distance between two kinds of drones always. It is a fixed bound, right. In dynamic separation, different drone pairs have different separation criteria depending on relative sizes, depending on relative speeds, but that is a little bit more dangerous and also more complicated system. So, we need to have CDNR or conflict detection and resolution warnings in drones similar to the ATMs. So, there will be a collision volume, there will be a collision avoidance threshold, there will be a self separation volume, and there will be a self separation threshold. So, we need to provide information for avoidance of a conflict and avoidance of collision, just like we do it in an aircraft using systems like TCAS. So, the actual conflict resolutions will have to happen between drones collaboratively. We have to ensure that we do not have to have any third party input for this, it has to be in a collaborative manner. Now, how will drones know about no-fly zones? How would they know? I mean, so one way is geofencing. That means you bind the no-fly zones in artificial walls which drones are avoid, and they are managed by a conflict management system. So, the drone cannot penetrate these walls. Okay. So, this is one way. Now, there are three methods to mitigate geofencing intrusion or failure. Okay. One of them is, as I said, no-fly zones. The other is you activate the no-fly zone during flight, and the third will be there will be an alert given when you are near the no-fly zone. These are all attempts to ensure that the no-fly zones are very strictly and safely implemented. When you operate drones in urban areas, you have tremendous challenges. Okay. In urban areas, because of the interaction with the wind, with the buildings, it will cause lots of eddies. These eddies are going to affect the flight behavior of the drones. Okay. This can cause very turbulent winds, and drones being small in size may not be able to withstand these turbulent changes. So, because of these turbulence and eddies, the drones can deviate from the planned path, or they may overcorrect and lead to problems. Alright. So, currently only gusts which are less than 5 meter per second, these are manageable by the drones, but then we have to look at more and more accurate systems to predict and also making the drones capable of handling larger gusts. Let us move now to the current scenario in India as regards UTM and this. Now, in India, each drone and the pilot with the current drone regulations, they have to be registered with the DGCA unless the drone is less than 250 grams, in which case we do not require registration, but anything above that I think we need to register, right. Now, the Indian airspace has been divided into green, yellow and red zones. Green zones will allow free movement of drones, yellow will some restrictions, and red zones prohibited. Now, the flight plan of the drone has to be uploaded and approved by an ATM in yellow and red zones. Okay. Green zones is free flight, no problem. And in India, the DGCA has come up with the airspace map, which is a dynamically changing environment called as a digital sky. This is a very interesting idea. Here is a snapshot of the digital sky, and for those who are interested, you can have a look at this website. You can see. Now, at the sovereign border of the country, 25-kilometer area comes under the red zone, okay, international boundary. So, you just cannot fly any drone within 25 kilometers of the international boundary. It is prohibited. So, that is a red zone unless you obtain specific permission and approvals for that. Then you have yellow zones. Okay. In the vicinity of the airport, those zones are much smaller, and then there are other zones. Then there are some at the airport locations, there are red zones again, you cannot fly in those areas. So, this map is dynamically changing, and therefore, the zone restrictions may be created depending on some activity happening. So, it is always there is a indication that we should check this map before we actually conduct every drone flight. Now, what is expected to happen in our country in the future? In the future, we are looking at a possibility of hundreds of fully autonomous drones flying around in the city. We will probably have a unique RFID, radio frequency identification device for the communication, navigation and surveillance of drones, just like we have in ATMs. Okay? The epitome of free flight concept is that there is no human involvement in flight except for the conflict management and solution, right. So, this is the epitome of free flight, and the role of the conflict management system is to maintain the airways, to enforce the geofences, and if there is any unmanned, unidentified flying drone or a rogue aircraft, it has to be tracked. Information regarding weather also has to be provided in real time for the drones to incorporate that in their flight planning. That is the role of the conflict management system. In summary, the free flight concept for removal of ATC and making the plane self-sufficient is much more relevant and important for the operation of drones. So, we need to shift the conflict detection and resolution responsibility, and also the separation from the ATC. We have to move it to the onboard systems. The advances in communication, navigation and surveillance and research avenues in modern aviation, there are plenty of them because of these challenges. Drone deliveries require a new UTM system. It cannot be under the jurisdiction of the same ATM that we have. It has to be separate. The air taxis will follow the UAS urban air mobility system. Possibility it will be integrated with the UTM. Okay? But the main challenges remain as the conflict detection and resolution, separation between the two flying vehicles and between the flying vehicle and the obstacles, how to handle the wind gusts which are generated in an urban environment, how much is the battery or the fuel life that you need to ensure safe operations. These are some of the challenges. But it is a very interesting field, it is a very challenging field, it is a beautiful area for lot of research and new initiatives. Thank you for your attention.